Welcome everyone to the presentation. My name is Jesus Miguel García Corrostieta. I am a professor of Universidad de la Sierra. And on behalf of the co-authors, Aurelio López, Samuel González, Adrián Pastor López, I would like to present you our research entitled Improve Argumentative Paragraph Detection in Academic Thesis, supported with unit segmentation. So this is the task that we will present. First, let's look at our overview. We're going to have an introduction, related work, corpus, model for detect argumentative paragraphs, identification of argumentative segments, and using these two models improve the detection of argumentative paragraphs. And finally, some conclusions. So, in thesis, students presented their ideas, and these ideas need to be sustained. To be sustained, these ideas, we use argumentation. With that, we give backup to that ideas that the student presents. And if there is no backup in that ideas, the instructor usually needs to tell to the student to correct their cases. Okay, so what is an argument? An argument is only a set of statements that could be, for example, premises, that individually or collectively provide mainly support, but some kind of post to a client. So a simple argument contains at least one premise and one conclusion. Here we have an example. We have a conclusion, which will be the generation of an ontology for domain represents a challenge. But why could this generation of an ontology represent a challenge? So this is the part of the support that the students need to include in all their ideas. Since to generate them requires the services of one or more experts in the domain. So there is some difficulty in the generation of ontology. So this is the structure of an argument that we are looking in the thesis of the students. One of the tasks is take this paragraph and classify as an argumentative or not argumentative. In this case, it is an argumentative paragraph. Another task is to detect these segments. The segment, for example, for the conclusion, this is an argumentative component segment. And another segment is the premise, which starts in this word since. Okay. So in this paper, we present a method which improves the argument, the detection of argumentative paragraphs using two methods. The first, an approach to identify directly the argumentative paragraphs, and also to join the information of the segmentation units that we see. For example, how many segments that could be premises or conclusions. So using these two informations, these two results of our methods, we can provide an improved method. Okay, so the related work, and we have some corpus and the legal area, and in the social area, or even in the political discourse. The classification of argumentative paragraphs has been approached using traditional categories, for example, using argumentative categories and features basis in mode and the tense of the verb using a traditional machine learning algorithm, for example, decision tree, but also to detect if some clauses or sentences are argumentative or not argumentative. Some researchers have used, for example, word pairs, verbs, text statistics, using also machine learning classic algorithms like Bayes classifier. Or, for example, in the case of Buddhas, use a logistical regression for that task. Another approach is the unit segmentation of these argumentative segments. For example, Sardinos use a part of speech and keywords, and also distributional representation with conditional random field algorithm. Also, Azure, for example, use a deep learning approach using a P by LSTM with semantic, syntactic, and structural features. Okay, the corpus that we use, it is based on the TP collection, which has thesis and research proposals from the field of computer and information technologies. These theses are in Spanish language, and this collection, and we only use the problem statement, justification, and conclusion, because these sections has a lot of argumentation in them. The annotation process was developed using an annotation guide, and the team consisted of 7 annotators of different fields of linguistics, and the corpus has 444 sections. And from this corpus, we have several levels of annotation, but for this presentation, we focus only in paragraphs and segments. And the paragraphs we annotated achieve a fair level of Cohen-Kappa. And for the identification of segments that could be a premise, a conclusion, or a segment that doesn't have any type of argumentation, we achieve a moderate level of Cohen-Kappa. Okay, so in this corpus, we consider only the paragraphs that has at least 2 argumentative components, because our method will try to find these segments. If there are not segments, then it will be a problem for the method. Okay, and we use 1,174 paragraphs, 830 paragraphs with argumentation, and 344 paragraphs without argumentation. This was for the task of detection of argumentation in paragraphs. And to detect the segments, we use the labels of BR, which represent the beginning of an argument, of a segment, and ER, the inside of that segment with argumentation, and O, which represent another label. So these are the numbers for corpus, and this corpus is available in this web address. In this, also in this paper, it's explained all the details of the corpus. Okay, the first method is the detection of argumentative paragraphs. So this task was approached as a binary classification, and we tried to detect paragraphs with argument and paragraphs without argument. We use a tenfold cross-validation using scikit-learn toolkit, and the classifiers, we use the toolkit of scikit-learn. We use traditional machine learning algorithms as support vector machine, random forest, naive Bayes, and decision tree. And we use these features, these lexical features, bigrams and unigrams, syntactic features, which use the lemma, and also the grammatical category taken from the part of the speech of the word. Also, we use the semantic feature. It's a word embedding polyglot. It came from, it was trained using the Spanish Wikipedia. We also use indicators, which are 5 categories of argumentative markers. We also try with the document occurrence representation, which is a vector-based representation, and which considers all the size of the corpus training. And this size of the corpus training indicates the importance of each word for each document. So it's the way that it's represented, this document occurrence representation. And the results of this are, for example, we see that the lexical category achieves with a decision tree, achieves quite good at one macro with 0.75 of F1 macro. And then we try some combinations. For example, we try with lexical, which is the best, with all the other kind, and we see that lexical with indicators, with also the decision tree, achieve improved classification of argumentative paragraphs. Okay. Another method that we investigate was to identification of argumentative segments. So this task was approached as a sequence classification of argumentative text. So in this example, we have a text part of conclusion, and here we have the labels. This is what our method tried to do. If we give these words, the method will try to classify as BR or IR or O, all each one of these words. And the classes that we use, as I say, were BR, IR, and O. These are the data used for this task. And the features explored in this task were lexical, syntactic, lexical, syntactic, indicators, and structural. We use a nearby tokens information to this task, 15 tokens from the left side and from the right side of the word that we are classifying. And this is the size of the window, 15 tokens. In this example, I explain what is the window. For example, for generation, if we consider a window of size 1, we only take one word for the left and one word for the right, and all the features of all the words that we are considering. Okay, so the features used are lexical features, that would be the word, syntactic feature, that will be the first part of the speech of that word. And then we consider the lexical syntactic feature, which use the syntactic tree to take the upper node, the right sylvan, and the parent node of the token. We also consider the indicator features to identify if that token is part of an indicator, argumentative marker. We also consider an structural feature to indicate if that token is the beginning or the middle or the end of a sentence or a paragraph or a section. Okay, so the results. We use a tenfold cross-validation employing conditional random field, and the best performance was observed using a window size of 15. As we see, a single feature, we achieve 0.54 1 micro, And if we make combination of this, as we see we take the lexical, the structural, and the indicators, and we achieve a 0.56. If we include the feature of syntactic, we improve a little with a 0.57, and if we include all the features, we achieve the maximum level with 0.5733. So the best model was using all the features, which achieved 60% of accuracy. So we join these two methods to improve the detection of argumentative paragraphs. And for that, we take the prediction of the argumentative paragraphs, and if that paragraph doesn't have any segments, then it's classified as a paragraph without argumentation. That's the way we make this fusion. We ensure that all the paragraphs that we are indicated as argumentative has segments. So we present a theory approach, which is more description using a decision tree. It achieves a 0.81 of F1 macro, and a second approach using a support vector machine, which achieves a little higher macro information. So with the decision tree, we can explain to the student maybe the rule used to came to that conclusion, to that result. So that's a good option. Okay, the conclusion, we present two approaches. One, a model more descriptive using decision tree, and another one more with the best efficacy using a support vector machine. We present also a method for the identification of argumentative segment using conditional random fields and the features we present, and we identify that the window of 15 tokens is the best to take information. We conclude that our method fusion ensures the identification of argumentative segments within paragraph with argumentation. And with these segments, they can be later fed to another model that can determine if that segment is a premise or a conclusion, for example. In future work, we will like to explore that method, take that segment and identify the premises and conclusions in that segments, and also detect the relations that are in between that components. For example, a support relation between a premise and a conclusion. And we would like to incorporate deep learning techniques also. And these are some reference. And thank you very much for watching this presentation. This is my mail, and I will be very thankful if you write some questions.